10.5, factoring x squared plus bx plus c, which is a trinomial. We're going to learn how to factor something that looks like x squared plus 9x plus 14 into the binomials that we're used to. So a binomial times another binomial. Remember, those were the factors. And we went from the binomials to a trinomial. We multiplied, we distributed, and made it look like that. Now we're going to learn how to go back from here and go backwards so that we can go either way. Well, to start off with, you need to know a couple things. You need to know that I'm going to refer to the letter b out of here, and that's 9, the coefficient. B is the coefficient of x right here. And I'm also going to refer to the letter c in this lesson, which is 14 out here. It's the constant. I want you to know that, so I may just say, look, we're going to use b right now, and I want you to realize, I want you to be able to go directly, where is b in the trinomial, or c. Some examples of you might be used to maybe what's going to happen here, or to kind of see an overview of what's going to happen. I'm going to give you a trinomial, and you're going to give me the factored form. And I had a math teacher a long time ago, and he would just say factor, 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 like the farmer on the tractor. I still, to this day, I have no idea what it means. But you know what? I finally got to say it for my class, so there you go. Anyways, I'm going to give you a trinomial, and you're going to give me the factored form. If I gave you a trinomial like this, the result, you would give me something such as x plus 2 times x plus 7. You're like, whoa, how did you go from here to here? Well, that's what we're going to do today. You're going to see that this x squared actually comes from the x's, these first terms. X times x is x squared. You're going to take a look at b and c, and you're going to come up with two numbers that we can put in those positions so that when we use them correctly, they will give us the trinomial there. It's really cool. So for instance, I don't know if you can see, but 14, I don't know if you can see the relationship right there between 2 and 7. How can we use 2 and 7 to get 14? Well, we can multiply those. We got 14. But also, how does 2 and 7 and x relate to 9x? Well, a positive 2 and a positive 7 would give us a positive 9. So I'm just trying to get you to see maybe where some of that might come from for you. And we do have a way, obviously, we have a method to figure that out. But I'm trying to get you to see ahead of time here. If I had something like x squared minus x minus 12, I would have two factors. Again, I'm just going to take the x. The x is always going to be the first term in the binomial. And then I look at term c right here. And I'm thinking, wow, what are some combinations of c that when I multiply them, just like we did up here, 7 times 2, or yeah, 7 times 2 is 14. What are some combinations times two numbers? I multiply them, oh yeah, 3 and 4. In fact, a positive 3 times a negative 4, well, that would be a negative 12. That would actually work. And then I would look at, well, positive 3 and a negative 4, if I was to add them, I would still have a negative 1 left over. And if you look right here, negative 1x. So maybe some of it's starting to sink in a little bit. X squared minus 2x minus 15. Again, I just break it up. I know I'm going to have two factors here. I got the x from here, and then first thing I do is, like, you wouldn't even see that yet, okay? And first thing I would do is look at them going 15, negative 15, or just 15, 15. Some factors of 15. 3 times 5, that's all I got, 3 times 5. So I got to use a 3 and a 5. And then I see a 2 here, and I go, how can I use 3 and 5 to get 2? I'd have to do some kind of a subtraction, but I could do it, which is awesome. So I put a 3 here and a 5 here, and you can see that if I did positive 3 times negative 5, I would get negative 15. And a negative 5 plus 3 actually leaves me with a negative 2. So this is the overall theme. How do we go from here to factored form? And that's what we're going to do. I'm going to teach you how to do that. It's cool. Let's go get this over here. So, example 1. Factor x squared plus 6x plus 8. And here we go with the solution. Step 1. What I did is I just went ahead and put a little skeleton right here, a little skeleton template of what I know my answer is going to look like, and then I'm just going to work on filling those in. Step 1 is the easiest one. The first term of each binomial, this is a binomial factor and a binomial factor, each binomial factor is x. Let's just do it right now. Put the x in there. Boom. Boom. Okay? That was about as hard as it gets for the first term. Step 2. B is 6 and C is 8. Remember where I pulled that from. B is 6, C is 8. Now here comes the tricky part. I want you to just think, well, what two numbers when multiplied will equal 8? Will equal 8. And I'll bet you probably are coming up with some right now. 2 and 4. But they need to be the same two numbers. When I add them, would give me 6. 2 and 4 added together, that's 6. Yeah. And 2 times 4, yeah, for sure. So why don't we just try that out? Let's. What am I using? Green. I'm gonna try to write left-handed here. So if I just had 2 and a 4 and a 2 and a 4, 2 times 4 is 8. So I'll just put a 2 in there, and I'll put a 4 right there. I like how 2 plus 4, that's 6. 2 times 4, that's 8. So I should be able to go, well, this should work. And the only way really to do it is to double check it. So I gotta work right-handed here. So really quick, I'm just gonna write up here and see if it works out. The x's, x times x is x squared. So I just took this times that, distributed it to here. That gives me a positive 4x. And then a plus 2 times x, that's a positive 2x. So I just took this guy here and went this way and this way. 2 times 4 is 8. And you can see when we combine like terms here, we are going to get, that's going to equal to 6. So x squared, 6x, 6x plus 8. That's fantastic. So we just did our first, we took our first trinomial, and that looks messy. We ended up with x plus 2 times x plus 4, and we even worked it out and proved that it was correct. All right, I want you to go for it. You have 2 right here, so go ahead and pause and do it, and then I'm going to work it out right now for you. See you in a minute. Okay, so I know that from this, a binomial, the first term is always x. These are both addition right here, so I'm going to just go ahead and put my addition sign in there. I know it has to be that. Now, I look at, we got B is 4 and C is 3. And I'm thinking, well, what two numbers, when I add and when I subtract them, when I multiply them and when I add them, will give me these results right here. Well, what are some factors of 3? 1 and 3. That's all I got. 1 times 3 is 3. 1 plus 3 is 4. Wow, we're done. I know we're done. If I work that backwards, it's going to check out. So that's the thought process behind it. So you would have gotten x plus 1, x plus 3 for the first factor. Over here, let's just go ahead and write out our template here, our skeleton. Everything is addition here, so we know it's going to be addition inside. We always know the first term. We can at least get that part. We can get halfway home with that. Now I'm looking at the 6 right here, and I'm trying to come up with some combinations. 3 times 2 equals 6. But does 3 and 2 added or subtracted get me to 7? What else gives me to 6? 6 times 1 gives me 6. Oh, hey. 6 plus 1 equals 7. All right, that's what I want. So you can see it took a little bit extra work on my part to try to, figure out what was going to work here. So, but the same numbers, 6 times 1, 6 plus 1, and I got what I wanted. I got my C and I got my B. And because we're doing addition here, I can put them in there any way I want. I'm just going to put the higher one on the back right there. So x plus 1, x plus 6 is the factored form for x squared plus 7x plus 6. Why do I know that work? I know if I go ahead and do the distributive property like we've been doing for binomials, I'm going to end up with the same trinomial that we started with. Okay. All right, example 2. Factor x squared minus 5x plus 6. There's going to be something a little different here. So I have a subtraction sign in front of b. Same start. The first term of each binomial factor is x. So you go ahead and draw out your template there. And let's just put x in right now. Now I'm not going to put any signs in there because we're going to have to figure that out to make it work right. I know that b is -5, and I know that c is 6. And so I start thinking, well, what two numbers give a product of 6? What two factors multiplied against each other, product, multiply, will equal 6, and a sum of -5. And we can just come on over here, and we can just kind of test it out. Let's see. We were just doing that, 6 and 5. 6 times 1 is 6, and I can do some negative in there. So let's see. What if I did -6 times -1? -6 times -1, would that give me a +6? It would. Would it give me the same thing down here? -6 plus a negative plus a and it wouldn't. That would give me actually -7. So that didn't work. That one did not work. So I'm going to erase that. What other factors? 3 and 2, right? Well, I'm going to need a positive here. I know I'm going to have to get some kind of a negative, so I'm just going to start off the bat. So -3 and -2. If I multiply those, I get a +6, so I'm good with that. What about here? I put a -3 in here and a -2 there. A -3 plus a -2 definitely would give me a -5. So there we go. We got our two numbers that we need. And what's going to happen is I'm just going to go ahead and insert them either way. -3 and -2. And we have our factors. And we're gonna work this out just to make sure that we did, in fact, we will get the same trinomial up there. I just want to be sure for you. And I want you to see what happens because we have two negatives in here, and I want you to see what happens. So I'm going to do x times x is x squared, and an x times a -2x is a -2x. -3 times -3x, I'm sorry, -3 times x negative 3x, and then a negative 3 times a negative 2 is a positive 6. And I think you can see, combined like terms, negative 2x and negative 3x is the same as a negative 5x plus 6. And you can see that we got x squared, negative 5x, plus 6, plus 6. So we had to think about this. This is a great template for you to use when you're trying to figure out the right combination that's going to fit in there. And then of course you definitely, if you're really not sure, you definitely want to check to work with that way. No reason why you can't get 100%. All right. Oh, cool. Time for you to go for it. And pause it, do it, and come right back, and I'll have it ready for you. X squared minus 5x plus 4. I'm just going to go ahead and put my template there. I know I'm going to have x for the first two. Chances are it's going to be negative and negative again. But let's just make sure we'll do it the old-fashioned way. And I'm trying to think what two numbers times themselves will give me the c, which is 4. So that's a big question mark right here. The other question mark is, I also want the same numbers when I add or subtract them to equal negative 5. Okay, what are some factors of 4? 1 and 4, and I know 1 and 4 can get me to 5 somehow. You know, 1 plus 4 is 5. But 2 times 2 is 4, and 2 plus 2, that's 4. So it's got to be. It's got to be 4 and 1. So let's just put a 1 and a 4 here. And the thing is, I know when I add them together, I'm going to need a negative. So I'm just going to go ahead and put that negative there, because a negative times a negative gives me this positive 4. I like that. And then if I put it down here, a negative 1 plus a negative 4, remember that's still negative, so we're just going to add that together. That negative 1 plus a negative 4, I'm in the hole $1, and now I'm in the hole another 4, which puts me a total, I'm down $5. So this works very well right here. So I'm going to go ahead and insert the negative 1 and the negative 4, and we have our answer for this trinomial right here. The orange trinomial, number 4, go ahead and draw out your template. You might have seen a pattern right now. If you see negative, positive, go ahead and do it. You know you're going to have negatives. You also know you're going to have x's in the first term for the binomial. And now we just got to figure out what's up with 12. We need some factors of 12 that when I add them together, they're going to equal negative 7. Wow. Well, what times what equals 12? 3 and 4, 12 and 1, 6 and 2. Which one of those do you think when we add them together are going to give us 7? 3 and 4, of course. So 3 and 4, but I need it to be a negative 7, so it's going to need to be a negative 3 and a negative 4. So when I add them together, I get the negative 7, but when I multiply negative times a negative, I get my positive, and I know we are looking great. We're looking great for that. Okay. We're going to pause here, and I'll see you in class, and we'll do a lot of this with some word problems so that you can see some application and how does this actually fit in your life.